Hello there. Our objective in today's video is to build a GUI, or a graphical user interface, in Rust. But considering that we're moving from solely developing command line programs, a good way to transition is to get started with TUIs, text-based user interfaces, as it introduces us to the event-driven architecture that is common in GUIs. So as usual, to avoid complex business logic, the app we'll be developing is simple, but should give you the tools to get started creating your own programs, which is hopefully why you're watching this video. Alright, so anyway, with that out of the way, we'll be building a TUI and a GUI pick-a-say, where pick-a-say is the command line program we developed in the first video project of the series. If you haven't watched that yet, I'll link it down below. Anyway, for the TUI, we'll build this. And upon startup, the user will be greeted with 1, a text input where we can specify what Pikachu will say, and 2, a checkbox to indicate whether Pikachu is in a Pokeball or not, just like in the pick-a-say command line program. So once you fill those in, say hello, you can tab through the inputs, press OK, it displays this. Or you can check return, press OK, and it shows the Pokeball. And you can also exit. Alright, so this is the outcome you should get. Now for the GUI, doing cargo run, shows this. Pretty intuitive UI, same logic as the TUI. You can say something like, hello, press generate, and Pikachu shows up saying hello. Or you can put Pikachu in a Pokeball, press generate, and Pikachu shows up in a Pokeball. Alright, so let's get started. Alright, so for our TUI, we'll be using a crate called Cursive, as it hides some annoying details and it is overall pretty easy to use. But before we get started, it's important to note that Cursive makes use of the system library ncurses, which means you must have that installed in your computer. So I'm currently using Ubuntu, so to get it installed, all I had to do was say sudo apt-get install lib ncurses w5 dev. Okay. I already have this installed, so I won't run it, but if you're developing for Windows and or Mac OS, I'll leave a link in the description for the equivalent installations. There are several backends that you can use. I don't think ncurses is available for Windows, but you can install pancurses and whatnot. So yeah, find that in the description. So with that out of the way, let's get started with this new binary crate. We'll add dependency to cursive. Let's go to our cargo toml, and I have it opened right here. Copy this and we'll add it right there. Right. So this done, we'll go back to our main, and to start the app loop is pretty simple. We just say use cursive, and here in main, can close this. We can just say let mutable app equals cursive default, and then we say app.run. Alright, so here we are, as I mentioned, just starting our event loop. Usually in command line programs, we're just limited to one input at a time, so we never really have to worry about event-driven systems. But for GUIs, on the other hand, we might have to handle multiple inputs, like I don't know, multiple key presses, mouse clicks, and whatnot. So since we can't really predict which input will be triggered first, the program runs a sort of a conceptual while loop to monitor things. And if you don't really get this right now, don't worry, it will become clear once we actually start handling some events. Anyway, if we run our program right now, so just cargo run it, of course it will compile a bunch of things, but as you'll see, all we get is a blue screen. Now usually that's not very good, but this time we can just Control C it, so to close the program. So, but once this finishes compiling, if it takes too long, I'll speed up the video now. Alright, so as I mentioned, good old blue screen. But let me just Control C and it closes it just fine. Anyway, let's actually bring some life onto it with let's bring our Pikachu onto scope like so. As first order of business, we'll just display Pikachu on a text view. So we'll say cursive views and we'll import a text view. Right. Now in here, to actually display it, we can just add a layer with our Pikachu and a text view onto the app. Now, what we'll say is app, add layer, and we'll say text view, which is what we just brought onto scope, and new Pikachu. Alright. Now I mentioned layers and views, so what really are them? Well, views are the main building blocks of the cursive library. An example of a view is the one that we're just using, the text view, which just holds text. You can also use views for buttons, checkboxes, dialogs, progress bars, and a lot more. Now layers are important because cursive uses them to create a stacked display of views, where the last added view is the active one. Anyway, basics out of the way, let's run our program. Oops, cargo run, and I think we have an error. Oops, I didn't save. My bad. And there we go. There's our Pikachu. But this text view isn't good enough. So let's... Other than Control C to terminate the execution of the binary, our program isn't really listening to anything. Let's remedy that by adding the option to quit the program by pressing the escape key. Which conveniently is pretty simple. We can just say app.add global callback, and in here our event will be key, escape, and our callback will be s.quit. Of course we have to put s in there. And before I forget, we don't really have keys here, so let's just say use cursive. I think that's event, yeah, and key. Alright, so in here, other than the layer that we added previously, we're adding a global callback. What does that mean? It means the disclosure isn't being called right now. Instead, we're sort of registering or adding a callback so that whenever we have a specified event happen, which in this case is the escape key being pressed, we can just call back to it. That's why it's a callback. So now you're hopefully starting to understand a bit better why we have this conceptual infinite loop. We could have several callbacks, and this loop is just waiting for any of them to get called back. Anyway, there isn't much point to me running this part because you can't really see my keyboard, but if you're following along, try pressing escape when the program is running and you'll see it terminate. Alright, so regardless of our progress, our app still feels a bit rough around the edges. So let's do something about that by rather than describing what a dialog is, I'm going to just show you. So I've added some new code. I brought in dialog, and I put a dialog around our text view Pikachu. Now let's bring the terminal. We'll say cargo run. And there it is. So now you get why it was rough around the edges. Anyway, that's neat, but the really cool thing about this is that we can, let me press escape to close the program. The really cool thing that we can do is that we can come here and say dot button will say OK, and another closure. We'll just say s.quit. And now if we run it, cargo run, we see that we have the little button, which if we press, closes the program. And that's pretty cool. Anyway, now that we have these basics out of the way, let's add layers onto layers onto layers on. Alright, so for this section, we'll write more than just a couple of lines of code. So usually what I would do is I would sort of just write the code and then speed up the footage. But this time around, I've written the code in advance, and now I'll just copy and paste it. I'm not sure which method is best. Let me know if one is better than the other, and I'll just go with that. But anyway, I'll paste it in for now, and now I'll just go over it. But before getting started with any logic, I want to point out that I am bringing the Pokeball and some cursive stuff into scope. So if you're following along, do that. But now, as we mentioned previously, the first thing we want to do is create a form page where the user can input a message for Pikachu to say. That's what we're doing in this input step that we're calling in main. Going over it, we see that we are adding a layer with a dialog inside, which has a title, some content, and a callback button. Now the title is just simple text. The content is a list view to display our text input, so the edit view, and our checkbox in a scrollable list container layout. And our callback button just populates this PicAssay option struct that I created right here. Good example of using lifetimes in actual code if you're looking for one. But yeah, so going back, here we're just populating with message and the Pokeball return state. But how are we actually doing that? I'll get into it. In more detail, to achieve that, we're giving each user interactable view a name with this name function, which, by the way, is conveniently brought into scope with our first use, this identifiable. And now, having a name, we can get its content or simply check if it is checked with this colon name. So here we're getting content, and here we're checking if it's checked. I mean, of course, maybe we misspelled a name, or we try to get something that doesn't really exist in the window. So this colon name returns an option, but that's all right. Nothing that unwrapping can solve. And having all this, we're ready to move on to the next step, where just like in the previous PicAssay, we determine that the text that will be displayed in accordance to the user input, and that's done right here. And having done that, we pop our previous layer in a pretty stack-like fashion, so we can add this new result layer with a usual title and a button just to quit. Alright, so hopefully I went over that alright. Usually it's easier to do with the speed coding, but I don't know. Let me know how it was. And yeah, this result step is being called in here, so after the button. Right, so call result step, go to the next layer, pop the layer, add the new layer. Let's get to the fun stuff and actually run this. Now doing cargo run, shouldn't take too long. There it is. We can now say something like hello, press OK, it shows up, and now it closes. We can then cargo run it again, check this, press OK, now we get a Pokeball. Alright, you'll note that in the one that I showed in the beginning, instead you could press OK, and instead of quitting, it would go back to the previous layer, and you also had an exit button on the previous layer. So if you want to try that out as sort of a additional exercise, go ahead. But I think this was a long introduction. And to create our graphical user interface, we'll be using GTK. Where GTK is this free open source and well-established library for building GUIs. Just like Cursive, GTK also relies on a system library. To install it on Ubuntu, you can simply do sudo apt-get install lib gtk-3 Right. Again, for other operating systems, I'll leave it in the instructions below, or in the description. I'll leave the instructions in the description below. Alright, being done with this, we can go to our newly created binary crate and add the dependency to the Rust GTK binding. It's a bit more complicated than usual, but not by much. All you have to do, that's why I'll write it specifically instead of copying from crates.io. You'll say GIO, and I'll explain what GIO is in a second. And then you'll say dependencies.gtk version. The latest version is version 0.9.2, as far as I know, and features, which will say v v3 underscore 24. Alright, let's save this. And first we have GIO, which is this guy, and it is needed for GTK, as you'll see in a second. And then we have, as I spoiled, GTK itself. To find the system GTK version that we're using in features, all you have to do is say the package L, and then you can look it up by gtk-3. Now, as you'll see right here, I'm using 3.24, and that's why I have v3 underscore 24. Alright. And being done with this, we can get started with some skeleton code. Let's come in here and let's paste this in. Now I can close all this for now and save it. Alright, so let's go over it. You'll see that the general flow is actually pretty similar to the TUI, which is why that was the introduction. Anyway, we have the conceptual infinite loop with app.run, but before we get into that, let's go to the beginning of main. So here we set our app ID, which uses this is JTK style, uses sort of reverse DNS. So you say com dialogs PKSA GUI, which is the name of this specific binary crate, but you can call it whatever you want. Following convention, of course. Now flag is this second part, they are what define sort of the behavior of an application. There are several examples, and I have that open in here. So as you can see, we're using flags none, which is the default, but you have several. You have a service as launcher, and we'll just use this first one. But if you're feeling adventurous, you can go over it. Again, I'll leave this in the description. Anyway, yeah, for now we'll use no flags, which is the default, but moving on. After this, we set a callback for when the app is active. And in here, we create a window, we set a title, we set its default size, and then we show it, as otherwise it will just remain hidden. It will be there, but it won't show up. And then lastly, as we mentioned previously, we have here our conceptual infinite loop. The one difference is that, as you can see, we're passing all command line arguments. Alright, let's actually run this now. If we go to here and we do a cargo run, hopefully it won't take too long, but if it does, I'll speed it up. And I think I will. Speed it up. And there we go. All that wait for a very exciting empty window. But anyway, let's add something to it. Alright, for this section, we'll need a couple of new things from GTK, other than the application and the application window. Let me minimize this. We'll also need a box, a label, an image, and orientation. Right. Now with this there, all we have to do is this. It's this magic of copy and paste. Again, as usual. Usually I would speed up this footage, but let me know if that's better or worse. Anyway, so yeah, importing a couple of new things, and then in terms of logic, here we're creating a layout box, which is used to organize our widgets. We're specifying that we want a vertical orientation, so our widgets will be placed one on top of the other, and with a spacing of 0 in between them. Okay. After that, we create our message in a label, and we add that to the layout. So you sort of see how the pattern is. We create an image and we add that onto the layout. And then finally we get our layout and we add it to the window. This is what we just had before, so window show out. And hopefully this will be a more entertaining display. Just come here, we'll say cargo run. And we haven't saved it, so wasn't that all that much entertaining. We'll do cargo run, and I just noticed I forgot to put Pikachu in the folder, so I'll be right back. Alright, so a couple of changes. As I mentioned, I didn't have Pikachu in the image for Pikachu anywhere, or in the specified path, so I brought that in. Images, same level as source, we have pikachu.png, and I noticed that the image that I have was a PNG and here was a JPEG, so I just changed that to be PNG. But in any case, now we can do cargo run, and there it is, our good old surprise Pikachu. Cool. But before we move on, I just have one quick note. You see that we are defining layout from our Rust code. And I mean, our example is pretty simple, so it's sort of easy to see if any problems arose and why they are arising. But what if you had a huge layout? right? Well, you're in luck, because JTK provides us with a debug view for widgets. And to make use of it, we just use that JTK debug environment variable, and we set it to interactive. Then we do cargo run. So doing this, we'll see that our program runs, but then it also opened this window. And this is pretty cool because it can help you visualize, for example, if we open our window, you see that it sort of flickered. Then we have our layout box, our label, and our image. So yeah, again, not super helpful with our very simple example, but yeah, feel free to make use of it with your huge layouts there are to come. Right, talking about huge layouts, let's move on to some, maybe not huge, but definitely more complex layouts. So building UI procedurally, like we just did, gets very hard as your program goes larger. So to solve that, I want to introduce you to Glade, the UI design tool that comes with GTK, which will allow us to build our UI declaratively. Alright, so to make use of Glade, in Ubuntu, all I had to do was say sudo apt-get install Glade. If you are on Windows or OS X, I'll leave the link for the installation down below. Right, I've already installed this, but having this installed, I can now go to my terminal and I can say Glade, which some stuff will run, but it will open a window like so. Now, by creating a new file or a new project, clicking this icon will give me a window like this, which pretty much gives me a tool, a drag and drop tool for creating a layout style. Alright, to sort of introduce you to this, let's work at the first part together, and then I'll speed up the rest so you see the end result. First, we want to add our application window. So let's go to top levels and look up application window. Double click it, adds it onto our canvas. Right, looking good. Now let's add, or before we do that, let's actually give this an ID. We'll call it application window 1. And now let's add our sort of our global layout box with 3 items inside. So it will be a JTK box. We drag and drop off the window. Now, just like in our code, we can see that we can set the orientation to be vertical and spacing of 0. So pretty much just the code. But yeah, let's call this what I mentioned, global layout box. And now moving on, let's create our form box. So I'll create a new container and I'll add it in there. Now this will be our form layout box, and it will also have 3 items and an orientation vertical. We'll have 3 items because one is the message box, one is the Pokeball box where you say if it's returned, and the last one is a button to generate our figure. Right, let's start by creating the message box. So box, we add it onto there, and we'll say message input box. But now this one will be horizontal, we'll have 2 items, and will be homogeneous. What this means is that both items that we add on the box will have the same size. So this is just so that it looks nice. Okay, now let's get our first display item, which will be a GTK label. We'll add it onto there, and we'll say something very useful, Pika Pika. And this will be our message input label. Now in control, we want to add a JTK entry for where the user will enter their message. In here, we can just call this message input. We can pretty much leave everything as default. It doesn't really matter, but if you want to play around with it, go right ahead. Okay, and I think this sort of gives you the gist of it. I'll now speed up the rest, and I'll see you in a bit. Alright, and once you've finished, hopefully it will look somewhat like this, but if not, put your own twist to it and, I don't know, have fun. But now that we're done, we can just save, and we'll save this in our root of the project, which, by the way, I created a new binary crate called Picasay GUI Glade, and I pretty much just copied everything that we had in the other one onto this one, just so that they're separated, but they're the same. Right, yeah, so we'll save, we'll call this layout, and we'll use the .glade extension. Okay. But now that we have this, how do we make use of it in the code? So let's go back to the code right in here, maximize this. Right, so our objective here is to really just remove all this. We'll get rid of it and instead, super fast coding. There it is. Instead, we'll include our layout as a string, and we'll build it. We'll build from the string. Okay, so we'll be building directly from our layout, which, by the way, if you want to see the file, it's really just XML. So, pretty cool. But going back to main, so what's happening here, have it as a string, build from a string. We then get our window. Now I think we called it, let's go back in here, we called it application window 1, so that's, oops, I erased it, that's where we're getting the object from. So we use the names that we had on Glade to refer to them in code. And then we tie the window that we just got from the builder to our app, and we show up. So let's run this. I'll close Glade, and I'll cargo run. Now this will take a little bit, so I'll speed it up and be right back. Alright, and with that, there we go. And it's looking great, but it doesn't really have any functionality. If I say whatever, I press generate, nothing really happens. If I turn on the switch, press generate, nothing really happens. So let's remedy that by and the way we'll do this is actually pretty similar to how we did it in our TUI. Inside our connect activate, let me paste this in, and now as usual, let's walk through it. Oh, actually, one more thing. Below here, we want to say image output dot hide. Okay. Alright, VS Code is already spoiling that we have a problem here, but we'll get to that in a sec. Before we get there, you see that just how we got our window, we can get the other objects, such as our message input, our button, our message output, and our image output. Okay, so yeah, and then we can then use these to assign, for example, a specific callback, such as for when the button is clicked. Now let's just go over the logic and then we'll see the problem in the logic. In here, we'll have our button clicked, and what we want to happen is that we want to get the message input, right? So whatever we get in the entry, and then display that or update our message output label with that. And yeah, but one thing that's important is that we don't want to show the Pikachu just being surprised without saying anything. So after we show all the layers, we'll be hiding the image output. So that's why we're showing the image here. I'm sort of jumping around, but hopefully that made sense, right? This is a callback, so it only gets called when the event is triggered. So in this case, the button is clicked. So for now, this callback is just registered. We show all, but we hide the image output, and the order is important. Okay, so now back to what we were discussing before, the callback. We get the message input that the user entered. This has a type of G string, so what I'm doing is I'm checking if it's empty. If it's empty, we just want to display the image created by dialogs, else we want to set the message as that as a string. Okay, then we set the text in the message output with the formatted bubble, and inside our bubble our message. Okay, then we show the image output, because again, the Pikachu will be hidden. But again, as we're being spoiled, closure may outlive the current function, but it borrows image output, which is owned by the current function, may outlive borrowed valued image output. Alright, so this is happening because once the callback function is set, it might get triggered anytime during the application's lifetime. But by the time the callback is triggered, image output variable will already have gone out of scope. And to fix this, you may think, oh, okay, let's just move ownership of image output, right? So we'll say move. Now we're moving the ownership of that into the scope, and so we won't have an issue. But then another problem occurs because we're making use of it here. We're hiding it after it. So just display it borrowed of moved value image output. And a simple fix to this is to clone it. And before you complain, just let me explain. Or if you're not complaining, then just be happy with it. But I'll explain why cloning in this case isn't bad. People usually complain about cloning, but you'll see in just a sec. We'll call this image output clone, and we'll say image output.clone. Right? Now we'll be using instead the clone in here, and we'll be hiding the normal image output. And now we can move, and we don't really have any errors. Alright, so again, we are... Oh, just before, in case you're curious, we're still moving message output and message input into the closure. But we're not cloning them because we're not using them like we do image output. But anyway, back to cloning. This clone we're making is actually pretty low cost because considering that gtk-rs is just a wrapper around GTK from C, it makes it so that we're only copying the pointer and not the whole data structure, which is usually why people complain. And yeah, the only thing left to do is to put our Pikachu in a Pokeball. But for now, let's see how this is looking. Let's save it and go to our terminal. Oh, by the way, we saw that we had a couple of unused uses, so I just removed them. But cargo running this, hopefully it won't take too long. But if it does, I'll just speed it up as usual. Shouldn't though, right? Just one. And there we go, okay. Alright, so as we can see, our Pikachu is not being displayed because we hid the image output. And now we can say hello. Pressing generate. There we go. We got our Pikachu saying hello. Alright, let's move on to putting our Pikachu in a Pokeball by which, nicely enough, is pretty easy to do. So we're reaching the end of the video. So if you're feeling daring, pause the video right now and try to do it yourself. But with that said, here's how to do it. Select it all, because that's pretty much where the change is happening, with exception of this. So we're just, as usual, bringing, or getting that object from the builder. And now in our callback, we are checking if the return switch is active and keeping that in this is return variable. Right. Now we check if it is returned. If it is returned, we set the output text to an empty string because we don't want to have Pikachu saying things from inside the Pokeball. And we set the image from file. Now, one thing that I want you to note is the path. So when I was creating the layout in Glade, I added this to this images folder to our project. And note that it is in the same level as source. But we're doing ./images/pokeball.png. Okay? So it's the path from the layout.glade file. That's something important to note. But anyway, we'll set it as a Pokeball. Else, so if Pikachu has not returned, we will set it to Pikachu and format the message in the normal way. And that is it. Let's go to our terminal. Let's cargo run it. And with that, we should be done. I don't think this will take too long. But yeah, it took me forever to make this video, so hopefully the wait was worth it. Anyway, alright, here, Pika Pika, we'll say hello, generate, it shows up, perfect. Now if I say returned, generate, we see the Pokeball, yay! And then again, I can change the message. If I generate and that's active, it won't show. But if I remove it, generate, then it shows. So yeah, there it is. Again, to prepare for this video took me forever. If you're in the Discord, you know. But again, hopefully it was worth it to wait. And thank you so much for watching. I guess I'll see you next time.